Welcome back, welcome back, welcome back. I'm Lisa Blackburn. This is my YouTube channel for everything I want to talk about science and math. This is part 3 of AP Notes, Unit 1 on, what do we call this? Describing matter. All right, so we had gotten to the point before the board cut out last time where we were talking about the types of reactions, and we made it to combustion. Now, combustion, there's a little bit of debate about what is combustion. You're like, these people are nerds, they debate dumb stuff. Well, this is one of them. Some books will say that anytime you add oxygen, it's combustion, like this. But most books say no. And in the AP test, what it said on the AP Chemistry Teachers Facebook group was that when they talk about combustion, they're talking about burning a hydrocarbon. So there's a hydrocarbon plus some oxygen, makes carbon dioxide, water, and energy. Some combustion is incomplete, and it will produce carbon monoxide, smoke, and ash. Now, we all want to be real careful because people accidentally kill themselves with carbon monoxide poisoning. How could you accidentally kill yourself with that? How does that happen? They'll start a car, a lawnmower, something in their garage, and it's not well ventilated. They breathe and they die. How else? People in Georgia do this one, where we are. We have a little cold snap and we kill ourselves this way. How do we do it? The power goes out. People are sitting in their house and they're cold and they're hungry, and they look out on their deck and they see their grill. And they know they've got some frozen hamburgers in the freezer, and they're like, I'll just bring it in, I'll cook my frozen hamburgers, and I'll have heat and food. Is that a good idea? No, because the grill is incomplete combustion, is going to put carbon monoxide in your house, and you're going to die. Go out and put on your coat and go cook your hamburgers outside and bring them back in. Now, the only way to do it safely would be if you could put your grill in your chimney so that the carbon monoxide would go out of your house and be ventilated. But people kill themselves. They also do it with space heaters that are not burning correctly. They kill themselves. We kill ourselves if it gets a little cold here. We really can't handle it. We're meant for our winters to get into a low of 60. After that, we start killing ourselves on accident. So, be careful. And I'll tell you one thing that annoys me about television. They will try to do a romantic scene on television or in a movie, and they'll have 500 candles. Candles are incomplete combustion. 1 or 2 in your house is okay. But like Michael and what's her name on The Office, when they did 5 zillion candles when he proposed or whatever, they would all be dead in that office. That is way too much incomplete combustion in a small space. So don't kill yourself with candles or anything else on accident. We're going to be good chemists and not kill ourselves. Okay. All right, so that's incomplete combustion. Formula, weight, molecular weight, molar mass, all the same thing. And so you have to add up the molar mass, and where we do that is we look at the periodic table. We look at those masses, the decimal number on the periodic table. So, for example, if we wanted the molar mass of H2SO4, you list your chemicals that make up the compound. You write how many you have. I have 2 hydrogens, 1 sulfur, 4 oxygens. Does everybody understand that? Then you look on the periodic table and you look up the mass and you multiply them. So hydrogen is 1, sulfur is 32, oxygen is 16. I'm rounding. Sometimes in college they won't let you round. They make you put all the decimal places. So just know that. We'll find out. I think AP Chemistry makes you go to 2 decimal places, is what I read on the Facebook group. Okay, so you multiply them and add them up. 2 times 1 is 2, 1 times 32 is 32, 4 times 16 is 64. 98 grams per mole, or 98 AMUs. Okay, if you're going to use it as a conversion factor, it's grams per mole. If you just want its formula weight, it's AMUs. Okay? Here's another one. It's made of calcium, nitrogen, oxygen. I have 1 calcium, but notice I have 2 nitrogens. See how the 2 is outside the parentheses? And just like math, the number outside the parentheses goes for everything inside the parentheses. So I have 2 nitrogens, and 2 times 3 is 6 oxygens. Is that good? You multiply them and add them up, and it's 260 AMUs. Not good, Melanie?
It's 164.
Oh, I added it wrong. 164. Correct that. I don't know what I was writing down. I like it. I like it that I was wrong and not that you didn't understand that. That makes me happy. Okay, percent composition. This is what Atticus was talking about at the beginning of the period. Percent composition from formula weight. Sometimes it's useful to know the composition in terms of percent of elements in a compound. For example, you got copper in a compound. Is it worth it to go buy the land and make a copper mine? Well, let's find out. So here is an example of a chemical. This is not copper. This is what makes the smell of spearmint. I really like spearmint. I think that's my favorite mint, and spearmint oil. So we want to do the percent composition. You list your chemicals, you write how many, you do its molar mass, and you add it up. 150 total mass, just like what we just did. Then you take each of these and divide it by the total. So 120 divided by 150 times 100 is 80%. 14 divided by 150 times 100 is 9.3%. 16 divided by 150 times 100 is 10.6%. This is the answer, these percents, but you can check it and see if it adds up to 100. If it does, you might be right. But the answer is the percents, not 100. That'd be easier if the answer to all of these problems was 100. You could just write it down and not do the problem. But it's not. Y'all remember doing that in honors? I see some nods. Good. If not, that's okay. Just learn it now. I'll wait on y'all for a second. Okay, we already talked about this, Avogadro's number. You buy eggs in dozens. You buy socks in pairs. You get chemicals in moles. That's why we have these cute little moles. Let's see if they can see it. Oh, yep, they can see it in Facebook land. Look how cute that mole is. I think this one's really cute, too. Y'all gotta see how cute he is with his glasses. Show it to Facebook land. I mean, YouTube land. I used to put my videos on Facebook Live. I don't do that anymore. They take them down. Okay. So that's our unit. It really has nothing to do with the animal. It's just animals are cute and they're fun to stick everywhere. Look at that little drawing in play. Okay, so and it is 6.02 times 10 to the 23rd atoms. It's a convenient amount, usually about a handful of most of the chemicals I get. Figured out by Amadeo Avogadro. That's what he really looks like. If you look up his picture, he looks like that. An unusual looking fellow. I like the look. The slightly paranoid look in his picture. Y'all can look him up. That's what he looks like. Okay, so I think it's a painting of him. Okay, so you do conversion factors with this. So you use it in conversion factors. So you have to figure out the molar mass. So the molar mass of nitrogen off the periodic table is 14, lithium is 7, water is 18. We already talked about that. Okay, so how do we do these mole problems? You write what you know. You write the units of what you know in the denominator. You think of a conversion factor and you do the math. So there's the one we did. Did we do that one for a warm-up? No, we did a different one. So we have how many moles of carbon? 4 moles. There are 12 grams per mole. So it's 48 grams would be a mole of carbon. So if you're asking for formula units, the units are going to be AMUs. If you're asking for the conversion factor, will be grams per mole. Do you remember that from honors? Okay, so don't be confused. Another thing that you can learn is you can calculate empirical formulas from percent composition. So this is probably we did in honors, but it's something that's off AP problem too. So these problems, they're going to give you a bunch of percents of chemicals. You write them all down as grams. The reason why you write them down as grams is because you can have any amount you want, and what you want is 100 grams, because that way you can just change percents to grams without having to do anything. If that doesn't make sense, don't worry about it. Just know that wherever it says percent, you're going to list them as grams. You're going to, for each one, divide it by its molar mass and get a number. you're going to write it down to a bunch of decimal places. Don't round off here. We need decimal places because we need to know which one is the smallest. We look at these, and the smallest is nitrogen, 0.8837. Is smaller than 0.8838, right? That's why we had to have a lot of decimal points, so we can figure out which one's smallest. Nitrogen is smallest. Then you take the smallest one and divide it into all of them. So, this divided by that is 6. This divided by itself, of course, is 1. This divided by that is 11. And this divided by that is 1. These are the subscripts for your empirical formula. So the answer would be C6H, H11, 0. Now, by tradition, you always write hydrogens next to carbons. The whole hydrocarbon thing. This part of the you wouldn't be expected to know that though. It'll either be multiple choice or else you wouldn't lose points for that. But if you remember it, this is not wrong. It's just like etiquette, chemistry etiquette. All right, how do we feel? So those are supposed to be nylons. To me, it looks like the green pants with nobody in them from the Dr. Seuss book. Anybody read the green pants with nobody in them? Little kids get freaked out by that book. They get seriously scared if you read it to them. If you want to freak out a 4-year-old, read them that book, and they will get scared. The green pants with nobody in them. Okay. So those are your subscripts. Now, sometimes this does not come out as whole numbers. They'll come out as a half, as a 0.5, and you multiply everything by 2. Okay, in college, sometimes it might be a 0.3 where you have to multiply everything by 3. But in high school and probably on the AP, you wouldn't have to do that. If you're given the mass of a compound in these problems, that means you can get the molecular formula, the real formula, the unreduced formula. How you do it is you look up the molar mass of the empirical formula and divide it into the mass they give you. Now, I did it there, but I meant to do it here. Okay, so here, this is the molar mass of my empirical formula that I had. There were 3 carbons and 4 hydrogens, so my molar mass was 40. They gave me a mass of 121. That goes into there about 3 times. So 3 is my multiplier. I take my empirical formula, multiply everything by 3, so it becomes C9H12. Do y'all remember that from honors? If you're given a mass, that's what you do. Okay, quantitative information from balanced equations or stoichiometry. We are not going to do the whole thing because y'all get ahead of the other class for some reason. Usually third period does everything more, but for some reason y'all move faster than they do. So we're just going to talk about the first problem here, because we don't want to get ahead of them. Okay, whoops. There's our green pants. Okay. So, stoichiometry is the mass and quantity relationships among reactants and products. It's what the coefficients or the number of moles tells you. So, how do you do these equations? First, write the balanced equation. Then write what you know under the chemicals and what you don't. Make sure your units are consistent. If you have kilogram in one place and gram in another, it's not going to work. They need to all be grams. You look up the molar masses on the periodic table if grams are in the knowns or unknowns. You add them up for each chemical and write them under the chemical in the reaction. If you're not converting with grams, write those ratios under the chemical too. Sometimes you write Avogadro's number. Sometimes you write 22.4 if it's liters of gas. Do you remember that? Those numbers? Okay, good. And then you write the mole ratio, the coefficients as a ratio. You draw a U to know the order you're supposed to multiply in. You set up your conversion factor train tracks, and then you do the math. Okay, so that's step by step how to do a stoichiometry problem. And then I'll show you a problem. And that'll be the last thing we do today after I show you 1 gram. And then tomorrow we'll finish with the other ones, the ones that might have liters or atoms. We'll do a limiting reactant problem, and that is everything for this unit. The first of 7 units. And don't y'all feel pretty good about this 1/7 of the class? We'll see. All right, so let's see a problem. So for example, you're making banana flavoring. That's why I had that palm tree up there. You have 45 kilograms of isoamyl alcohol and enough acetic acid to react with it. How much banana flavoring can you make? This is a lab we did in my honors chem when we made, remember when we made wintergreen and banana and all those? Yeah. Those of you who didn't have any, I know you're sad and you want to make banana flavoring. We might. I don't know what lab we're going to do. Okay, so first of all, the consistent units. We don't want this in kilograms. We want it in grams. So first of all, we're going to change those kilograms to gram, 45,000. Now we check to see if our equation is balanced. It is, so I put a little check there. That lets me know that you checked to see if it was balanced. I write what I know, 45,000 grams under the isoamyl alcohol, and what I don't know, how many grams of banana flavoring can it make. These are grams, so I know that I need molar mass, and that's why I have M&Ms on the periodic table, is because what goes with delicious graham crackers? M&Ms. So everybody imagine yourself eating a graham cracker. I'm mentally putting all natural peanut butter on mine first, and then dropping some M&Ms on it and eating it. I don't like not all natural. It's like eating peanut butter flavored Crisco. It's got to be Smucker's, but that's what's on my graham cracker, okay? So everybody put that in your head. Grams go with M&Ms, okay? So we look up the molar masses, because these are grams, off the periodic table and write them there. The ratio is the coefficients, and these are 1 to 1. You start with what you know and draw a circle around to what you don't know, and that tells you the order that you're going to multiply things in. First, you write down what you know, which was our 45,000 grams of isoamyl alcohol. I abbreviated it IA. In college, you'll probably have to write out the formula. And on the AP test, you'll have to write out the formula. I push the grams of isoamyl alcohol to the bottom, and then I go around my U, and I notice that grams are right there, so that goes down here in this denominator. What goes on the other side of the fraction bar? This grams, right, that line right there, grams per mole, per is a fraction bar. Do you know that from math? So what's on the other side of it? Mole. So I write moles right here. What number is understood to be with this mole? 1. It could say grams per 1 mole, but I need to write that 1 mole there. I push moles of isoamyl alcohol to the denominator, and I'll go around my U to see what number goes with its moles. It's that one right there. That's my number of moles of isoamyl alcohol. What's on the other side of the fraction bar? 2 dots in math is a fraction bar. Did you know that? We remember writing ratios in math. You can write it as a fraction or as 2 dots. On the other side of the fraction bar is this right here, and that's the number of moles of banana flavoring. I write it right here. I push moles of banana flavoring to the denominator. I go around the circle, and there's moles. What number goes with those moles? Understood? 1. So it's that 1 mole of banana flavoring right there. What's on the other side of the fraction bar? 130.21 grams. Grams of isoamyl alcohol mark out, moles of isoamyl alcohol mark out, moles of banana flavoring mark out. I'm left with grams of banana flavoring, what I was supposed to have. I'll multiply everything on top, I divide by what's on bottom, and that's the answer. Y'all remember how to do that? Grams to grams. So tomorrow we'll say, what if it's not grams? We'll do a few problems, do a limiting reactant, and that's it for Unit 1. Yay! All right, like, share, subscribe. Science is great.